optical instruments. Let's start talking about a simple magnifier. A simple magnifier consists of a single converging lens. This device is used to increase the apparent size of an object. The size of an image formed on the retina depends on the angle subtended by the eye. So with a single lens, it is possible to achieve angular magnification about up to 4 without serious aberrations. With 1 or 2 additional lenses, which correct the aberration, the magnification of about 20 can be achieved. Angular magnification is defined as theta over theta naught, which is the angle with the lens divided by the angle without the lens. The angular magnification is the maximum when the image formed by the lens is at the near point of the eye. For Q equals 25 centimeters, we can calculate the maximum magnification as 1 plus 25 over F. Compound microscope. Compound microscope consists of 2 lenses, gives greater magnification than a single lens. The objective lens has a short focal length and the ocular lens has a focal length of a few centimeters. So here's a really cool picture. It's called a monster soup. As more people became exposed to the subject, this was what the public reaction was. So as we started figuring out that there were germs and bacteria everywhere. So a compound microscope, the lenses are separated by a distance L, where L is much greater than either of the focal lengths. Image formed is the same for the 2 lenses in a row. This is going, the lens that is closer to our eye is going to be called the eyepiece, and the lens that is further away is called the objective. So for an object, which is here, the image that we perceive it to be becomes really, really large. Okay, so the ray goes through the objective through the focal length, hits this mirror, goes through our eye, goes back, and this is where the virtual image will be formed for us. The lateral magnification of an object is given by Q1 over P1 or L over F naught. The angular magnification of the eyepiece of the microscope is given by 25 centimeters over FE. The overall magnification of a microscope is the product of the individual magnifications, so it's going to be given by minus L over F naught, 25 over FE, where F naught is the focal length of the objective and FE is the focal length of the eyepiece. So going back to this picture, this is the eyepiece, the eyepiece, and this is the objective, right? And this is the object that we are trying to see. Telescope. So there are 2 different kinds of telescope. The one is called a refracting telescope and the other one is called a reflecting telescope. Refracting telescope uses a combination of lenses to form the image, whereas a reflecting telescope uses a curved mirror and a lens to form an image. So in a refracting telescope, you have an objective lens and an eyepiece, and then you can see the image coming from really far away as being enhanced. In this case, the image is going to be coming in from far away, but then you have a parabolic mirror at the bottom, which focuses all of the light to one point, which is the focal point of your mirror, and that is then goes into your eye. Again, the eyepiece is the one that's closer to your eye, and this is the parabolic mirror. This is called a reflecting telescope. Some examples of telescope. For the reflecting telescopes, the largest ones are about 10-meter diameter. It's the Keck telescopes in Hawaii. The single mirror telescope in U.S. has 5 meters diameter, and it's on Mount Palomar in California. Refracting telescopes is the largest in the world, is at the Yerkes Observatory in Wisconsin, and it has about a 1 meter diameter. So here's another picture. I just wanted to show this to you. This is called a radio telescope, and it's in Puerto Rico. And this radio telescope occupies nearly 20 acres of a hilltop. The bowl of the telescope is 305 meters in diameter and 50 meters deep. It's made out of metallic mesh panels instead of solid metal. It reflects as just as solid metal surface would be, because the holes are much smaller than the wavelength of the radio waves. The detector, which is right here, is suspended in mid-air. It is at the focal point of this parabolic mirror above the surface. It's 137 meters above the bowl, and it's called a radio telescope. So, disadvantage of a refracting telescope: the large diameters are needed to study distant objects. Large lenses are difficult and very expensive to make. Very, very difficult to keep the imperfection out of glass as it becomes bigger and bigger. Also, the large weight of lenses tends to cause sagging, which produces aberrations. So can you imagine a mirror this big, like a lens this big, mounted on a telescope? Then you need really, really heavy panels to support it on. And so refracting telescopes are kind of hard. Reflecting telescopes help overcome some of the disadvantages of a refracting telescope. It replaces the objective lens with a mirror. Mirror is often parabolic to overcome spherical aberration. Light never passes through any glass, so we don't have to worry too much about glass. And now light doesn't really pass through the eyepiece as well. It usually goes through cameras or computers, so it reduces chromatic aberrations. Another thing that uses lenses are your cameras, right? So the camera basically has a lens, a lens over here, and then an eyepiece over here, and it basically lets the light in. You look at it, and then it exposes the film, and you take a picture. So basically, a camera, a lens, or a telescope would not be possible without combination of lenses, which you will be doing in the lab.